Hello, Geometry. Welcome back. Chapter 6, Lesson 4. This one should be hopefully a little bit shorter than the last one. I apologize for the length of that one. A lot of information we got to cover here. The triangle mid-segment theorem, Lesson 4. So a triangle mid-segment. So the central question, how are the mid-segments of a triangle related to the sides of the triangle? What a mid-segment is, that's just going to be the segment that joins two midpoints. A segment that joins two midpoints. That is a mid-segment. Okay? You can kind of use the words there to help you remember what it means. A mid-segment of a triangle. So on this diagram here on page 179, we have segment DE. For this to be a mid-segment, so if this is a mid-segment, that means these two have to be congruent. D has to be a midpoint. And E has to be a midpoint. So these would also be congruent to each other, but not necessarily congruent to the ones on the other side. Okay, so that's the first characteristic of a mid-segment, is that it joins two midpoints. And we're going to have three key points with these mid-segments today. The first is knowing how to draw it, and it connects two midpoints. So notice I could draw how many mid-segments in this triangle. If I knew the halfway point for this, say it looks about right there, I could draw a mid-segment here, and I could draw one there. So I could actually draw a second triangle inside there based off these mid-segments here. And the area of the inside triangle is 1/4 the area of the big triangle. And it's going to come in handy on the assignment. The area of the inside triangle. You can stick 4 of these inside the big triangle, and you kind of see those 4 shapes right there. Okay, so the mid-segment. So when you look here on page 180, you kind of see what they've already drawn for us without so many things. And here's the characteristic that you're going to find, is that DF, if I look at DF, it is always parallel to a side. Okay? So each mid-segment is parallel to a side. So DF would be parallel to BC. DE would be parallel to AC, and then FE would be parallel to AB. Okay, so that's the second characteristic. The first is this joining midpoints. The third is going to be parallel to a side. And that's the second. The third one is the mid-segment length is half of the length of the side it is parallel to. So it's going to be half the length. The mid-segment length is half of the length the side is parallel to. And that's going to be an important one that we understand. So that's the third thing here. So 1, a mid-segment joins the midpoints. 2, it is parallel to a side, and 3, it is half the length of the side that it's parallel to. So if I have DF here, if DF is 5 units, obviously it's not. Hang on. Looks like it's probably about 2 units. So I'm going to guess there. So if DF is 2 units, that makes B to C twice that. That's going to be 4 units. Okay? That's the third thing there. It's going to be half the length of the side that it's parallel to. So that kind of covers all of these little things here that we're talking about with the triangle mid-segment theorem. Okay, again, the mid-segment of a triangle a segment that joins two midpoints of a triangle. It's parallel to a side. And it's half the length of that side. Put all these together here. The segment that joins two midpoints of a triangle, it's parallel to a side, and it's half the length of the side. Kind of your first example we want to do here, some of the first questions you'll have, actually, you don't have an example in the student journal, so I'm going to get some graph paper here. And this is the question. Given triangle ABC, if you need some time, just pause it and copy this down. Given triangle ABC and the midsegments XY, YZ, and ZX, show that XY is parallel to CB, so XY should be parallel to CB, and that XY is half of CB. So drawing on some of our algebra knowledge, we know that if it's parallel, they both have to have the same slope. So we need to find the slope of XY and CB. Okay, and we can use rise over run, or our slope formula is y2 minus y1 over x2 minus x1. I usually just use rise over run in this case. I have a diagram, I have the points. So the slope of xy, so I'm going to write it like this, xy slope, m for slope. So if I start at x and I go up to y, I'm going up 3, that's my rise, and my run is 1, 2, 3, 4, 5, 6. So the slope of xy would be 3 over 6, which equals 1/2. So let's check C to B. This is going to also help us with the second step, if I do this. So C to B, I'm going to draw a right triangle here. Let's go down here. I need rise over run. And again, you can use the ordered pairs for this and use the formula. So my rise is 1, 2, 3, 4, 5, 6. My run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So notice rise over run, these are both positive slopes. So the slope of CB would be 6 over 12, which is 1/2. So we've shown that they are parallel. And when you get to your assignment, you'll just get those numbers in there. Go back up to the top. Okay, so here it says use the graph, find the coordinates of, okay, here, this question. Question 4. Use the graph with these segments, show that it's parallel and it's half. So because the slopes of DE and CB are both, you have to find the slope and put it in there. DE is parallel to CB. These next two lengths are going to deal with the length. So you see that DE doesn't have a symbol on top of it. They want the length of DE and the length of CB. So that's the next thing we have to do with this, is find the length of CB. And so in this case, I need the length of XY, and I'm going to need the length of CB. So XY, here you see the Pythagorean theorem, or you can use the distance formula. So it's going to be the square root of 3 squared plus 6 squared. Okay, the rise over the run, the square root of the rise over the run will give that to you. So that's the square root of 9 plus 36, which is the square root of 45. And we probably will need to simplify that. So let's do a factor tree. Square root of 45, that's 9 times 5, that's 3 and 3. So I have a pair of 3's with a 5 left over. So that is 3 times the square root of 5. Okay, we can do a calculator and kind of get an estimate for what that would be, but the computer will want that exact one. So square root of 45, we know that to be about 6.7. Okay, computer will want the exact answer with the radical there. So C to B, here's my rise and my run. So it's the square root of 6 squared plus 12 squared. So that's the square root of 36 plus 144. That's the square root of 170, 180. Okay, let's do a factor tree with 180. Well, it ends in 0. So 18 times 10, that's 9 times 2, and that's 2 times 5, and then that's 3 times 3. So factor tree all the way down, I have a pair of 3's, a pair of 2's with a 5 left over. This is 3 times 2. The pairs go outside to play. Root 5. So this is going to be 6 root 5. So you notice it is twice the value. So that means XY is half of CB. A lot of algebra, a lot of work with this one. But again, doing these rise over the run on the category, that's going to help you both get the slope, rise over run, and the length of it, the square root of the rise squared plus the run squared. Make sure you square them and add them before you take the square root. And you see here that it is half the length. So these numbers that I just circled there, those are the numbers that would go in these next two boxes. What are the lengths? And they'd say, and then they go in these boxes again. The smaller value in the first box, the larger value in the second box. Okay? So those are kind of some of the trickier ones, and they show up right away. Let's look at some of the easier ones now. Give you a break with this. Okay? So it says DE is a midsegment of triangle ABC. Find the value of X. All right. So here, this is the midsegment. Remember, the midsegment is half of this. So if you take 28 times a half, you get 14. That's what X is. Okay? Half of 28. 15 is the midsegment. They want the long side. Take 15 times 2. You get X equals 30. Easy peasy, aren't they? We like these. Okay? Now here, this is the first characteristic. They told you this is a midsegment, so that means these are midpoints. Okay, so if this is 9, this has to equal 9 as well. Okay, the vertices of a triangle, they've given you 3 vertices of a triangle. What are the vertices of the midsegment triangle? So the midsegment triangle, that is what I referred to as the inside triangle, the one that is 1/4 the area of the big one. So let's get this drawn out. Let's see, my X values are -5, 3, and 1. So 1, 2, 3, 4, 5. Put it right there. Here's my y-axis, and my y's are 6, 8, and -4. Hopefully, I don't think this will all fit. Let's count by 2's. So the y's are going to count by 2's, x's can count by 1's. So the x is going to count by 1's. Y's are going to count by 2's. So -5, 6, 1, 2, 3, 4, 5, 6, 2, 4, 6. There's A. B is 3, 8, 1, 2, 3, 2, 4, 6, 8. There's B. And C is 1, -4, 1, -4. There's C. So, you can definitely draw this out. If you don't want to draw this out, all you have to find, what you need to find is the midpoints of each of the segments. So another way to do this is you can use the midpoint formula. Remember, the midpoint formula is you take x1 plus x2 divided by 2, y1 plus y2 divided by 2. What you're doing there is you're finding the averages. Okay? So if you want to find the midpoint of AB, so the AB midpoint, you would take -5 plus 3 divided by 2. It'd be -2 over 2, which is -1. And then you'd take the y value, 6 plus 8, and divide that by 2. So that's 14 divided by 2, and that is 7. So your midpoint for AB would be -1, 7. That'd be your first one. And we can check -1, 1, 2, 4, 6, 7. That seems to match right there in the middle where it would be. So here's your first midpoint. Now, if you want to use the graph, this one makes it a little bit easier. I just look at one value and then see where that matches up. So if I look from C to B, I see that they are 2 units apart. So if I'm going to be in the average, I have to be 1 unit. So I count here, okay, that's 2, half of that is 1, so I'm going to come back 1. I'm going to go up to my line. That's where it should be. That would be at 2, 0. There'd be another point. Let's check that here with A to C. So A to C, there's my kind of my triangle. I'm going to count how many it is. So it's 1, 2, 3, 4, 5, 6. Half of that would be 3, so I'm coming back 3. 1, 2, 3. Go up to your point. It should be right there. Remember, we were counting by 2's on the y-axis, so that looks to be like -2, -1. Hopefully that's what you were seeing as well there. So again, if you have the graph, I find it kind of easier to just look at one set of ordered pairs, count between them, and then count back half that distance. Okay, but there are the coordinates of your mid-segment triangle. Question 5, what is the perimeter of triangle DEF? DEF. Go for it. Go fast. Okay, so it looks like the perimeter of ABC is all given here, 38, 45, 13. So if this is 13, we have a mid-segment triangle. That's a mid-segment triangle. So if that's 13, that makes this 7.5, half of that. If that's 45 along there, that makes that half of it 22.5. And AC is 38, half of that would be 19. So we need to take 22.5, 7.5, and 19 and add those together. So that would be 30 plus 19, you have 49 units, whatever that is. Okay, so I just found half of them, add them all up. You could add your perimeter up of the entire triangle, take it divided by 2, or multiply by half. You have 49. Hey, multiple lines here. In diagram DE. D is a midsegment of triangle ABC. Okay, so DE is a midsegment. FG is a midsegment of triangle ADE. So we have a smaller triangle, and FG is a midsegment of that. They want us to find the length of FG. So if this length is 52, this is a midsegment of the big triangle, so that has to be, got it? 26 has to be half of that. But now that 26 becomes the bottom part of this smaller triangle. So what does FG have to be? Again, half of that. F to G has to equal 13. 13. Okay, let's wrap up these few questions here. The area of triangle ABC is 48 square centimeters. DE is a midsegment of triangle ABC. What is the area of triangle ADE? So we don't have a picture. I like pictures. It doesn't have to be drawn to scale. We got triangle ABC has an area of 48 square centimeters. DE is a midsegment, so I'm just going to draw DE. The midsegment triangle ABC. What is the area of ADE? Okay. Now remember when we drew those midsegments, if I draw one down here, I had 4 equal triangles, 4 triangles of equal area. So that makes triangle ADE 1/4 the area of triangle ABC. So 1/4 the area, so that'd be 1/4 times 48, which would be 12. We have a label, square centimeters. So 12 square centimeters. 1/4 of it. The diagram below shows a triangular woodshed. You want to install, who would build a triangular woodshed? You got issues yourself there if you're doing that. You want to install a shelf halfway up the 8-foot wall that will be built between the 2 walls. So 8 foot up, an 8-foot wall, and you want to install it halfway up. So that has to be 4, that has to be 4. Okay? And built between the 2 walls. So we have 15 foot here, 8-foot wall, and then 17 foot. This is lovely woodshed here. How long will the shelf be? Okay, well, if this is halfway up, you would want it parallel to this side, which makes this another midpoint. So what we have here is we have a midsegment. So if this is going to be 15, this is going to be 1/2 of 15, which is 7.5. Okay, so 7.5 feet is how long your shelf should be. How many feet should you measure from the ground along the slanting wall, from the ground along the slanting wall, to find where to attach the opposite end of the shelf so it will be level? Well, if you want it to be level along the slanting wall, so here's a slanting wall, you want to measure this up here. If you want it to be level, remember that's a midpoint. So it should be 1/2 of 17, which is 1/2 of 16 is 8, so that's 8.5 feet. Okay, that'd be 8.5 feet. You could drop this down, and this would be 7.5 feet. Okay, so I guess that's the application of it right there. And I think that covers 6.4. Okay, good work. Mid-segments of triangles, kind of some fun properties you can use and apply. Remember the 3 things. It joins the midpoints of the sides. it's parallel to one side, and it's half the length of that side. Those are the three main areas. So, good work. I'll see you in class.